In this video, we're going to look at how to find the surface area of three-dimensional shapes. Now, surface area is nothing more than the combined area of all the surfaces of this three-dimensional object. And you kind of think about it would be the total amount of area of paper needed to wrap the object. You kind of think about wrapping a Christmas present or a gift. And so it'd be how much that paper I need to completely cover all the surfaces of the object. Now, if I'm looking here at this first one, what you have to identify is the individual shapes and how many times they would occur. And we just kind of work through one side at a time here. And so I look at the base of this shape that I have. Okay, right here. And I'm looking, that forms a triangle. And I also have the exact same shape, it appears to be, right up here. And so I see that I have two identical triangles. And so the area of one of those triangles, so that triangle area that I have, is going to equal 1/2 times base times height, which would be 1/2 times 8 times 6. Now, I have two of them. And so I'd have to multiply that area by 2. And so I'm going to times that by 2. So that's that triangle. Let me write that a little bit different here. All right, so that's the triangle area that I have there. And we also have, I look, and I have this shape right here, which is a rectangle. And so to that area that I have, I would need to add not a rectangle, that area of a square, so I'd have to add 6 times 6, or 6 squared. Now there's no other side that looks like that. And then so I move on to the next geometrical shape that I see, which I see the side here that has one side length of 6 and one side length here of 8. So it has a side of 8 and it has a side of 6. So I have that rectangle and I only see one of them, so I'm going to add the product of 8 times 6 for that rectangle there. And so I have that rectangle. Let me make my square up under here so that way we can see. And then there's one side that I have left that is not accounted for. And so that one side that I have left is the rectangle that's on the far back side, back here in blue. Which has one side of 10 and one side of 6. So 10 times 6 is going to give me that area. So my surface area is going to be the sum of all those individual areas there, which would give us 192. Now my units are still going to be squared here because it's a form of area. So 192 miles squared. All right, let's look at another one here. So I look here at number 3. And we want to try to find that surface area again. And so I start looking at individual sides that I see in their geometrical shape. So the surface area is going to equal the sum of all the areas of the individual sides. And so I'm just going to start here at the very bottom. I got one side here where I have one side of it being 10 and one side of it being 3. And so that's a rectangle. So one area is going to be 10 times 3. So I have a rectangle here. Now I go find another side and say, okay, what's the next one I see? Well, how about these slanted sides here that we have? So I have one here on the right-hand side, which has, a side of 10 and an angle side of 4. But I also see the same thing over here on the left. So I have two of those rectangles, so I'd have to have 2 times the area of the individual one, which one side is 10 and one side is 4. And then I'm looking and say, all right, well, let's look at the very top here. I have a rectangle of the very top. It's right here in blue, which has one side of 10 and one side of 7. So far we've had 3 different rectangles here. And we have 2 sides left of this shape, which are the trapezoids, where I have one of these trapezoids here at the very front. And we also have another one that's on the very backhand side here. And it's be kind of hard to see with all this, but I have one on the side closest to me and the side far away. And so the area of the trapezoid, now there's 2 of them, so it's going to be 2 times the area of one of the trapezoids, which is h over 2, which h is 3.5, times the sum of the bases. Well, one base is 3, the other base is 7. So that's my trapezoids. And I had 2 of them. And so I add all those together, and we're going to get a surface area here that's going to be 215 feet squared. All right, let's look at one that's a little different here. Okay, so in this one, all right, so same game here, surface area equals, and I have to take and find the area of all the individual sides and add them together. Well, this one looks and appears that all of these sides here that I have labeled here in green are going to be the exact same. Where I have that one rectangle that would appear, actually, yeah, it's deceiving because of the orientation of it, but I have 5 of these rectangles that are all the same. So I find the area of one of those rectangles, and then I just multiply it times 5. So it'd be 5 times the area of one of those individual rectangles, which is 7 times 11. Now I am going to look at the bottoms and the tops, which are the same shape here, a pentagon. And so we have to find the area of one of these pentagons. And I'll try to draw a pentagon here. And we're given the measure of the apothem, which is the distance from the center to a side, and it's perpendicular to the side here. So we're given that measure. Now, what that does is if I go from the center and draw lines to the vertices, what you have is you have a little triangle here where I could find the area of that triangle because I know that one of the sides of this pentagon is 7. So the area of one of those triangles would be 1/2 times 7 times 4.8, which I get that, and then I look and say, all right, well, this is a regular pentagon, so there's actually 5 of those triangles. So I take that triangle measure and times it by 5, and that's going to give me 84. And so the area of that pentagon down there is 84 units, and we have 2 of them. We have one on the bottom and one on the top. So that's our pentagon. And so we would find that product and we'd get our surface area. So the surface area of this figure here is going to be 553 square yards. To find the surface area of the cylinder, it's kind of similar. You look at the shapes that you see. And so I see here at the bottom and at the top, I have circles. And so what we would have here would be 2 pi r squared. Because, well, the area of one of the circles is pi r squared, and I have 2 of them. And so I'd have to double that part. And we also have to account for the outside part of it. Like it's right here in the middle. So this section here, which is going to be equal to 2 pi r h. And so this is for the surface area of a cylinder. And so all I would need to do is plug in my information. Well, I have an r of 5, so 2 pi times 5 squared, plus 2 pi times 5, and h is 4. Which is going to give me a surface area equal to 282.74 meters squared. So the surface area of a cone, right, it has its own formula here, where the surface area of a cone can be determined by taking the area of the circle, pi r squared, and if we know the lateral area, the area of this lateral side, the slanted side, all right, that's going to be L. If I take the area of my circle and I would add pi r L to it, I would be able to get my surface area. So for this cone, the surface area would equal pi times 5 squared plus pi times 5 times 12.1, which gives us a surface area to be 268.61 inches squared. We'll talk about the surface area of a sphere. The surface area of a sphere, its formula is going to be 4 pi r squared. Well, the 2 here is a diameter. So r in this case is 1. So I'd put 1 in. So 4 times pi times 1 squared. And that's going to give us about 12.57 kilometers squared.